Okie dokie. Let's balance some equations. I've got 3 examples we're going to do here, and I've ranked them from what I feel is easiest, medium to hard. And hopefully when you guys read this, you're all going to think, oh, well, they were just so easy. And certainly I think the best way for you to make use of this video is to, once you see the problem, pause the video, try and do it completely on your own. And after you think you've got it, then watch the video and see if your answer matches mine. All right. Okay. All right. So let's start with this one right here. And this should be a fairly straightforward one. So let's see. Ammonium phosphate. Okay, ammonium is NH4. Phosphate is PO4. And phosphate, as you recall, has a charge of -3. Ammonium has a charge of 1. So we need to have 3 ammoniums to balance out that phosphate. Lead 4 nitrate. So that's Pb nitrate NO3. Pb has a charge of 4. We get that right from the name. Nitrate has a charge of -1. So that means I will need 4 nitrates to balance out that lead. All right. And those two react together to form lead 4 phosphate. So there's my lead. There's my phosphate. Lead, again, has a charge of 4. Phosphate has a charge of -3, so we'll just cross those numbers. That means this will be Pb3, PO4, 4. Done. And plus, what else does it form? Ammonium nitrate. All right, ammonium is NH4. Nitrate is NO3. That has a charge of +1. That has a charge of -1, so we're good to go there. So here is our skeleton formula. Skeleton formula. All right, so let's see what we have to do to balance this out. Maybe it's already balanced. I don't know. Well, let's have a look-see. There's my lead. There's the lead. Clearly, it's not balanced already. Look at all these ammonias I have. I have 1 there, 1 lead, 3 leads. I have 1 phosphate, 4 phosphates. Look at that. We got to fix all that. Now, one method that is offered up to a lot of students is to break all this down and look at the individual atoms. So you look at all the nitrogens and all the hydrogens and all the phosphoruses and all the oxygens and everything, and you break it all down, make a table, look at those individually. Forget all that. One nice thing to do is whenever we have a polyatomic ion, treat it collectively. I don't need to break this down into NH4s because I have I don't need to break this down into nitrogen and hydrogens because I have NH4s here and I have NH4s here. That means I have ammoniums here and ammoniums here. Just like I have phosphates here and phosphates here and nitrates here and nitrates here. So I'm not going to break it down. I'm going to treat that as a nitrate, 1 unit. That is a phosphate, 1 unit. Ammonium, 1 unit. So that's how we'll balance it. It's going to break it down individually. If we have the same polyatomic ion on the left and the right as a reactant and as a product, treat it collectively. So now, where to begin? Well, I'm going to begin with lead here. I have 3 here, but only 1 here, which tells me I need at least a 3 there. That gives me my 3 leads and my 3 leads. So the leads so far are fine. I might need to change that, but for right now, I know I need at least a 3. So 3, 3, good. Now, because I put the 3 there, that now gives me how many nitrates? Well, I have 4 nitrates, and I put the 3 out there, so I have 12 nitrates. This is the only place over here I have nitrates, so I must put a 12 there. There's no way around that, okay? So now I have 3 leads, 12 nitrates, 12 nitrates. Now, because I've had to put the 12 there, I also then on this side have 12 ammoniums. Over here, I just have 3 ammoniums. So let's fix that by putting a 4 right there. 4 ammoniums. Oh, I'm sorry, I have 3 ammoniums. So with the 4, that gives me 12 ammoniums, 12 ammoniums, 12 nitrates, 12 nitrates. 3 leads, 3 leads. Now, because I put that 4 there, That made the phosphates go from 1 to 4. Well, look at that. I have 4 phosphates. So I believe we're done here. So 4 NH4, 3 PO4, plus 3 PbNO3, 4 yields Pb3 PO4, 4, plus 12 NH4 NO3. Balanced. There you go. So remember, treat polyatomic ions when they appear as reactants and products collectively. All right? Okay, let's do a more medium one, I think. Manganese 4 oxide reacts with aluminum to produce manganese and aluminum or aluminium oxide. So manganese 4 oxide. So manganese, Mn, oxide we know is O2, but this is manganese 4. So that means that I'm going to need 2 oxygens because each oxygen is -2. I have a -4 and a +4. There's manganese 4 oxide. And it reacts with aluminum, which is just Al, to produce manganese, all right, Mn, and aluminum oxide. All right, well, aluminum acts as a cation. It has a +3 charge. Oxygen, as we know, has a -2 charge. So let's go aluminum, oxygen. Again, this is a +3. That's a -2. So we're just going to cross those. This will be Al2O3, aluminum oxide. So there is our skeleton formula. We are ready to go. Manganese 4 oxide reacts with aluminum to produce manganese and aluminum oxide. Okay, so let's see here. My manganese look good. Look at that, manganese. And as is my way, I'm going to save the oxygens till last. So let's look at the aluminums. So I have 2 aluminums here. Okay, well that should be easy to fix, right? Just put a 2 there. All right, am I done? Let's see. 2Al, 2Al. I've got 2 aluminums. I've got 2 manganese. Oh, but wait. I have 2 oxygens and I have 3 oxygens. Now, because this is an even number of oxygens and that's an odd number of oxygens, the only way I'm ever going to balance these is if I make the number of oxygens on both sides some even number. So what is the first even number I can use that both 2 and 3 go into? Well, obviously it's 6. So one way I can fix my oxygens then is to put a 2 here. That gives me 6 oxygens over here, which means I must put a 3 there. That gives me 6 oxygens over here. But now because I put the 3 there, I have to put a 3 there. Well, that's good. Okay, that's fixable. So let's see. I have 3 manganese. I have 6 oxygens. But you see here, when I first put this 2 there, that was before I figured out my oxygens. So you see now I have 4 aluminums. So this needs to now be a 4. So my final answer should be 3MnO2 plus 4Al yields 3Mn plus 2Al2O3. There we go. Okay. Let's look at this one here. Diiodine pentaoxide reacts with carbon monoxide to form carbon dioxide and iodine. So diiodine pentaoxide, well, the name tells us that's 2 iodines and 5 oxygens. And it reacts with carbon monoxide, which is CO, as the name tells us, to form carbon dioxide, that's CO2, and iodine. Now remember, iodine is diatomic, so it's going to appear here as I2, not just I. Okay, well this one looks pretty straightforward. I wonder why I thought this might be difficult. Let's see. I have 2 iodines, I have 2 iodines. That's awesome. You know, and again, this is my way. I'm going to wait to do my oxygens or hydrogens last. So we've got some oxygens. So right now, iodine's looking good. Okay, carbon's looking good. Carbon's looking good. Now over here I have 5 oxygens, and over here I have 6 oxygens, 5 and 1, that's 6 oxygens. Here I have 2 oxygens. So if we keep to our normal modus operandi, I would fix that by putting a 3 right there. Now I have 6 oxygens, 6 oxygens, but that's a big problem because since I put a 3 there, I need to put a 3 there, otherwise my carbons won't balance. And because I did that, I now have 8 oxygens to 6 oxygens. So we've got a problem here because this is always going to keep happening if I just try to match out the oxygens here. So something's got to give in that, and by that I mean we've got to break away from our normal plan and sort something out here. And what we're going to sort out is that right there. This is an odd number and it's a 5. So because oxygen only appears one place on the right or on the product side, the only way I'm going to be able to match this off is if my oxygens are a multiple of 5. Yeah, because this O5 is not changing. So any number that goes out here is always going to be a multiple of 5. So I need to make this a multiple of 5 too. So let me rewrite that. I2O5 plus CO yields CO2 plus I2. Okay, now as we said, in order for this to work, we're going to have to make this a multiple of 5. And the first multiple of 5 we get to, if we're dealing with 2, of course, is 2 times 5, or 10. So I'm going to put a 5 right out in front there. Now, because that's a multiple of 5, that tells me I have 10 oxygens. Well, looky here. I now have 5 oxygens over here, and if I put a 5 there, I now have 10 oxygens total, 10 oxygens, 5 carbons, and 2 iodines. Done. All right. And hopefully you disagree with me. You think, well, no, that was easy. I don't know why. Well, yeah, that would be a good thing if that were true. All right, so there we go. There we go. Now, this is the method for balancing pretty standard chemical equations. They do get much more complicated than this, and we have other techniques to do that. We can use half reactions and oxidation numbers and stuff, but that's for another time. This is just for your basic balancing chemical equations. So if you have any questions, you know how to reach me. Thank you.